So good afternoon, students. In the last lecture, we have learned about how to find the additive inverse and the multiplicative inverse in a given set of residues. So for example, if you want to find the multiplicative inverse of a number, suppose 8, in a set of residues Z10, then it will be very easier for you to find out the multiplicative inverse of it. If it is possible, then find out the multiplicative inverse. Otherwise, you have to state the answer that multiplicative inverse is not possible. So it is very easier for you to do the calculation with each number. Just you have to find out the 8 will be multiplied by a particular number b, and the b lies in the range of Z10, means from 0 to 9. And after the multiplication, you have to perform the mod operation, and the answer should be 1. So that will be the value of b. But what will be the case of in that way when you have to find out the multiplicative inverse of 8 in the set of residue 100? So it is difficult for you. Or if I say you have to find out the multiplicative inverse of 3 in Z201. So in that case, you have to find out the value of b in the range of from 0 to 200, and you have to do lot of calculation. So in order to make the task easier, there is one algorithm that is called the extended Euclidean algorithm, the same algorithm that you have to apply in order to find out the GCD between two numbers, and the same algorithm you have to apply in order to find out the multiplicative inverse of a particular number in the given set of residues. So what this algorithm says, just let me write. The extended Euclidean algorithm, you have to apply it in order to find out the multiplicative inverse of a particular number in a given set of residues Zn. So there is one condition that the GCD n comma b should be 1. So what is the value of n? N is nothing but the mod value. This one. N is nothing but the mod value 201, and b is the integer that you have to find from the given range. So GCD of that modulo operation number and the range of that number should be 1. Also, we do not need to find out the value of s. There's no need to find out the value of s, just you have to find out the value of t. We have to find out the value of t. So this value of t will be the multiplicative inverse of b in Zn. The value of t will be the, sorry, it should be t1. The value of t1 will be the multiplicative inverse of b in Zn. Okay, so let me write the algorithm first. Then I will state you one example such that you can better understand what I am trying to say. So the algorithm step is similar as the previous extended Euclidean algorithm. So first you have to know what is the value of R1. It should be maximum of n comma b. The value of R2 should be the minimum of n comma b. The value of T1 will be 0 and the value of T2 will be 1, and there is no need to find out the value of S. So my condition will be same, like we have to implement the while loop, and the condition will be while R2 is greater than 0. First you have to find out the quotition value, that is R1 divided by R2. Once you find it, Then you have to update the value of R, that is the residue, and the second one is you have to update the value of T, because we have only two variables over there, that is R and this one is T. So for first updation we have to perform on the value of R. So R will be calculated by R1 minus Q into R2, and finally the left shift. So the value of R2 will goes to R1 and value of R will be go to R2. Now the last updation, that is the value of T. The same technique you have to utilize at T1 minus Q into T2 and left updation, left shifting updation. So when the condition is terminated, when sometimes when R2 is equal to 0, then this condition will be terminated. Then you have to put one extra condition over there, that if R1 equal to 1, then in that case the B inverse, means multiplicative inverse of B, would be the value of T1, and if this condition is not satisfying, means R1, the value of R1 is not equal to 1, then you have to write out the multiplicative inverse is not possible. So by using this algorithm, you can find out the multiplicative inverse of a number in a bigger set of residues. All of the steps are similar as per the previous Euclidean algorithm, just you have to write down one extra condition over there, and you do not need to the calculation of the value of S. So let me state one example. Suppose the question is we have to find out the multiplicative inverse of 11 in Z26. So the same tabular format you have to write over there, like the value of Q, value of R1, R2, R, T1, T2 and T. That table you have to make in the exam also. Writing of the direct answers will not be acceptable. You have to first write the algorithm steps, then you have to write down this table and solve how to find out the multiplicative inverse of 11 in set of residues Z26. Here, this value indicates N and this value indicates B. Okay. So what is the value of R1? R1 will be the maximum value between B and N. So maximum value कितना है यहाँ पे? 26. So I will put 26 over there. Minimum value is 11 over there. Value of T1 is 0 and value of T2 is 1. Now find out the value of quotient. Because some of the students have weak mathematical calculations, so I will solve all of the steps clearly. So the quotient is R1 divided by R2. So just divide this one. So this value is called quotient. This value is called set of residue R or remainder R. So the answer is 2 over there, Q, and the value of R will be 4. What will be the value of T? The value of T will be T1 minus T2 into Q. Q का वैल्यू हम ऑलरेडी कैलकुलेट कर चुके हैं, सो T1 का वैल्यू है दैट इज 0, T2 is 1 and into Q that is minus 2. Now the step is left updation, left shift updation. So left shift में we have to update the value of R1, R2, T1 and T2. We not touch the value of Q, R and T. So 11 will be here, 4 will be here, then 1 will be here and minus 2 will be here. Now divide and find the quotient Q. R1 divided by R2, in that case The quotient value is 2 and the remainder is 3. The value of t will be t1 minus t2. तो t1 का वैल्यू कितना है मेरा 1 है, देन t2 का है मेरा -2 और q का वैल्यू है मेरा 2, that is 5. Then left shift. Now divide 4 divided by 3. The quotient will be 1 and the remainder is also 1. What will be the value of t? So t will be t1, t1 का value -2 minus q into t2, that is -7. Left updation 3, 1, 5 and -7. Now it will be 3 and the remainder will be 0, and in that case what will be the value of t? The value of t will be 26. Now updation, so here 0 and -7 and 26. Now the condition is terminated because R2 is equal to 0 and my loop will remain sustained only when R2 is greater than 0. Now if this condition is terminated, then we have to jump out of the loop and we have to check the further condition. The condition is if R1 equal to 1 or not. So we have to find out the value of R1 and check whether it is equal to 1 or not. So yes, luck by chance, it is equal to 1. If it is the case, the value of what the algo says, the algo says the value of T1 will be the answer. So what is the value of T1? Value of T1 is -7. This one. So -7 is the multiplicative inverse of 11 in set of residuals 26. So V inverse equal to -7. Because it is a negative value, you can convert it into the positive one by applying the mod operation. So 19 can be answered and -7 can be answered. Both the answers will be correct. Now question for you. Find the multiplicative inverse of 23 in set of residuals Z100. Now I am invoking the chat. You can calculate and tell me the answer. Just wait a minute. Yes, calculate and tell me the answer. So I should scroll up such that you can see the steps, what I'm going to perform. And you have to find out the multiplicative inverse of 23 in set of residuals Z100. Yes, Shubham, your answer is correct. Yes, Rohit, your answer is also correct. Other students, kindly solve the question. Yes, Arvind, your answer is also correct. So Q1, R2, R, T1, T. Maximum value is 100, minimum is 23. It will be 0 and 1. So find the quotient. So when you divide 100 by 23, so the quotient will be 4 and your remainder will be 8. And the value of t after the calculation and giving the formula by t1 minus q into t2, the answer should be 4. So left shifting, so 20 and 8 and 1 and minus 4. Now again divide. So if you divide it, so the quotient will be 2 and the remainder will be 7. So if you find out the value of t, the value of t will be 9 in that case. Left shifting, so 8, it will be 7, it will be minus 4 and it will be 9. So again you have to divide it. So the quotient will be 1 and the remainder is also 1. In that case, the value of t will be come out, that is 30. Now the left shifting, that is 7 and it is 1 and here it is 9 and it is minus 13. So when you divide it, the quotient will be 7 and the remainder is 0 and the value of t is 100. Okay, so left shifting, so 1 and it will be 0 and minus 13 and 100. So now the condition is terminated. You have to check it. The value of R1 is equal to 1 or not. Yes, it is 1. So the value of T1 is the answer. That is minus 13. So it is a negative value. So for converting it into the positive one, you have to perform the mod 11 operation over there. So 87 can be answer. So the answer can be minus 13 or 87. Now the last example over there. Find out the multiplicative inverse of 12 in Z26. Find out. The T1 and T2 values are constant and these are fixed by their inventors, that is 0 and 1. Yes, Arvind, your answer is correct. Other student find out the multiplicative inverse of 12 in Z26. Yes, Rekha, your answer is also correct. So Q, R1, R2, R, T1, T2, and T. So the maximum value is 26, minimum is 12, 0, and 1. So find out the quotient. So the quotient will be 2, and the remainder is also 2, and the value of T will be minus 2 if you calculate by the formula. So shifting will give you 12, 2, and 1 and minus 2. So again, you have to divide it. The quotient will be 6 and it will be 0. The value of T will be 30. So shifting will be 2 and 0 and minus 2 and 30. So now R2 is 0. So the condition is terminated. When the condition is terminated, you have to check out the value of R1. It is equal to 1 or not. If it is equal to 1, then the value of T1 will be the answer. That is the multiplicative inverse of 12 in Z26. Otherwise, if the value of R1 is not equal to 1, then we have to write that the multiplicative inverse of 12 in Z26 is not possible. So in that case, R1 is not equal to 1. R1 का value यहाँ पे 2 है. So that's why we have to write multiplicative inverse is not possible. Please do not write the multiplicative inverse of 12 in Z26 is 0. 0 is the value here. So आपको state लिखना है इस तरीके से पूरी तरह से statement लिखना है that is multiplicative inverse is not possible. So what is the additive inverse set? So my set of residuals that is indicated by the Zn is used to indicate the AI set, that is additive inverse set. Because if you remember that I mentioned one statement that in the additive inverse case, all the numbers in the range from 0 to n minus 1 having the additive inverse and those values are belonging to the same set Zn. So the whole set Zn can be used to indicate the additive inverse set in the encryption and the decryption process. But what about the multiplicative inverse set? In the multiplicative inverse set, suppose there is a value of Z6 and 1, 2, 3, 4, 5. So each value having additive inverse and that additive inverse is belonging to the same set of residual Z6. So Z6 is the additive inverse set. But what about the multiplicative inverse set of residual Z6? In the Z6 numbers, that is 0, 1, 2, 3, 4, 5, all of the values does not need to contain the multiplicative inverse that belong to the same set of residual Z6. ठीक है, जैसे कि देखा होगा एक मैंने एग्जाम्पल कराया था कि Z10 के अंदर 8 एक ऐसी वैल्यू थी जिसका मल्टीप्लिकेटिव इनवर्स पॉसिबल नहीं था. ठीक, लेकिन एडिटिव इनवर्स के केस में सारी वैल्यूज जितनी भी आ रही थी मेरी Z10 के अंदर उनका एडिटिव इनवर्स पॉसिबल था. So that's why we cannot use the same set of residues that is Zn as a multiplicative inverse set. So for that there is another symbol that is Z6 and O. So this multiplicative inverse set with the usage of this star indicate the values under the set of residual Z6 which having the multiplicative inverse possible and that belonging to the same set. So in the Z6, what are the values of A and B such that if you have multiplied or not after performing the mod operation with 6, the value will be 1. So if you find out 1, 1 and mod 6, so the answer will be 1. So 1 comma 1 is one pair and the another one is, what is the another set? Yes, the another set is 5. So 1 and 5 are those values. If you multiplied by a particular number in the same set, you will find out the multiplicative inverse. So Z6 star will be used to indicate the multiplicative inverse of Z6. And when we are talking about the additive inverse set, then you have to indicate it by only the Z6, not Z6 star. So ये आप याद रखना, जहां कहीं भी मैं यहाँ पे स्टार यूज करूं, आप बाय डिफॉल्ट समझना कि मैं मल्टीप्लिकेटिव इनवर्स सेट की ही बात कर रही हूँ. ठीक है? Just like the same example, in the Z7 star, it will collect all of the digits that having the multiplicative inverse possible and that belonging to the same set. इसमें किसी को डाउट अभी तक? Multiplicative inverse set, additive inverse, extended Euclidean algorithm, clear है? Can I proceed to the next topic or else I have to repeat that once again? Yes, another students, any doubts? Because the syllabus is vast, that's why I'm taking the speed. चलो कोई डाउट नहीं, तो आगे बढ़ते हैं. So the next topic is linear congruence. So it is the last topic of mathematics of cryptography, and in the completion of that topic, we will jump to the cipher algorithms. So as you know, there are two types of inverses, additive inverse and the multiplicative inverse. So what is the application of that inverses? Why we are calculating this additive inverse and the multiplicative inverse? Actually, what happens if there is a sender in the environment and there is the receiver? There is a process called the cipherment and the another one is called decipherment. So cipherment happens on the sender side and decipherment happens on the receivers. And by nature, the cipherment and the decipherment algorithms are inverse of each other. So that's we have to find out this inverses. क्योंकि ये दोनों ही nature में एक दूसरे के inverse हैं. So suppose sender wants to send a data having a value 10. Now this is a plain text. It is an original message and the communication channel between the sender and the receiver is not secure. It is insecure channel. So in that case, the sender has to perform the cipherment algorithm over the plain text 10. So suppose it uses the additive inverse algorithm. So additive inverse says that you have to add a particular value to the plain text, suppose 5, and the answer is 15. This 15 is called the cipher text. So this cipher text is going to the insecure channel and it reaches to the receiver. So at the receiver side, 15 is received by the receiver. Now the original message is 10. Because the cipherment and the decipherment algorithm are inverse of each other, so receiver has to perform the decipherment algorithm over the receiving cipher text. So in the decipherment, we have to detect the -5 over the perceiving ciphertext value. So 15 minus 5 equal to 10. That is the original plain text. So that's why additive inverse is used when there is a cipherment algorithm which implement additive inverse algorithm in order to generate the ciphertext, and the receiver uses the inverse of 5 in order to collect the plain text. The same thing happens over the multiplicative inverse case. Suppose the cipherment is generated by multiply the value of 5. Now the ciphertext is 50. I am sending the 50 to the receiver. 50 is received by the receiver. Because these algorithms are inverse of each other, so you have to divide 50 by 5. So as the inverse case, what we have to do 50 into 5 inverse. और यही हम निकाल रहे हैं तब से inverse inverse inverse. So that is the usage. So 50 divided by 5 equal to 10 will be the original answer. Now the question is, then what about the set of residuals over there? That is Z26 or Z100. Actually अगर हम only single value लेके ही plus और minus कर दें या divide और multiplication कर दें, so the attacker that is sitting over the insecure channel will easily get the plain text from the ciphertext by addition of the values or the multiplication of the values. ठीक? आप अपने mind से नहीं कर सकते, but your computer is able to do that. That's why we have to use it, the set of residuals. The set of residuals is used to generate the set of keys. ठीक है? तो इसके अंदर मैं कौन सी ऐसी की यूज करूंगी हर बार जिससे मेरी सिक्योरिटी इनहैंस हो. सो आगे जाके हम यही साइफर एल्गोरिथम्स देखेंगे कि किस तरीके से मैं अपनी सेट ऑफ रेसिड्यूल्स यूज कर रही हूँ in order to find out the effective cipher text that is fetched by the attacker, but it cannot be deciphered by the attacker. So that is the basic application of additive inverse and the multiplicative inverse in the cryptography. Now the linear congruence says that we need to solve certain equations which are linear in nature. ठीक है? With having one variable or more than one variable. And with having coefficients in set of residuals Zn. So the simple linear equation with having only one variable can be indicated as Ax congruence operator B mod n. B mod n. So this n belong to the set of residuals This A and B are the coefficients, and this X is called the variable. So you have to find out the value of X over there. So there can be one solution and there can be more than one solution, and sometimes there may be no solution. So how many solutions are possible? That we have to find out by the using of the concept of linear congruence. So how many solutions that we have to find out? My equation is Ax b mod n. And how many solutions of X over there? So for that we have to find out first the GCD of A comma n. GCD of this value and this value. And that is stored in another variable, that is D. Okay. Now the first condition you have to check if the value of B, this one coefficient, the value of B is divided by D, means B is divided by D, then we can say D solutions are possible. Else, the second point, suppose if B does not divide by D, then we can say no solution. Now, if it is the case of no solution, then you have to state just there is no solution possible and jump to the another question. Otherwise, if it is the first case true, that is the value of B is completely divided by D, then there are D solutions are possible. Then you have to find out what are that solutions. So if the first case is true, then you have to perform certain steps. What is the step number 1? The step number 1 says reduce the equation Ax congruent B mod n by divide by D both sides. Now the step 2. Step 2 says you have to multiply the multiplicative inverse of 8 on both of the sides. Multiply by multiplicative inverse of A in both sides. And now the step 3 is the last step, and there is a formula, that is the value of x can be found out, xk plus x0, that is the initial value, plus k and by d, where k equal to 1 to d minus 1. ठीक है, अगर एक ही सोल्यूशन है तो आप वैल्यू ऑफ x0 का सोल्यूशन निकाल करके आप क्विट करोगे, एल्स यू हैव टू पुट in this one equation in order to find out the further solutions. So the question is, suppose the equation is tan x congruent to mod 15. So this is the value of A, this is the value of B, and this is the value of n. So first step, you have to find out the GCD of A comma n. So what is the GCD? So GCD of 10, 15 is 5. So the value of D is 5. Now check for the solution, whether there is a possibility of the solution or not. So if we try out the first step, that B is divided by D or not. So what is the value of B? B is 2. The value of D is 5. So there is no division. So that's why no solution possible. You have to just write down no solution is possible. That will be your answer. Now another question, that is 14x 12 mod 18. It is the value of A, B and N. So first find out the GCD of A, N. So it is 2. So the value of D is 2. Now check for the solutions. So if B is divided by D, so what is the value of B? That is 12 and the value of D is 2. So 6, yeah, yes, it is divided. So we can say they are D solutions. कभी 6 solution मत लिखना, ठीक है? They are D solutions possible. So yes, 2 solutions are possible. And what are the 2 solutions? The first one will be x0 and the second one will be x1. How to find out the value of x0 and x1? That we have to learn by following the steps. What was step number 1? Step number 1 was you have to reduce the equation. Okay? What was your equation? Equation was 14x 12 mod 18. So the step 1 says you have to reduce the equation by dividing by the value of the both sides. So यहाँ पे भी 2 से divide करो, यहाँ पे भी पूरा 2 से आप divide करो. So that is 7x congruent 6 mod 9. Equation is reduced. Now the step 2 states that you have to multiply by the multiplicative inverse of A both of the sides. So it will be x and 7 inverse into 6 and mod n. Now remember the first property that I told you in the distributive nature in my second lecture. What was that? You have to distribute it. So 7 inverse mod n into 6 mod 9 and the whole mod 9. So for the 7 inverse mod 9, what should be the value? Okay. So just 7 is the A and it will be B and mod 9. Now think what the value you have to choose under the set of residues Z9 such that if you multiply it by 7 and after performing the mod 9 the answer will be 1. ठीक है? So अगर आप 4 से multiply करो so the answer will be 1 in that case. So 4 is the answer. 4 into and 6 mod n, the answer will be 6. 24 mod n बोल रही हूँ बार बार 9 है वो 24 mod 9. So the answer will be 6. So the value of x naught is 6 because there are d solutions possible and what is the value of d? That is 2. So at that is x naught and we have to find out the value of x1. Okay? So for the x1, what was the formula? That is xk x naught plus k n by d. ठीक है, अब k का वैल्यू यहाँ पे कितना है 1 to d minus 1. So ये मेरा फर्स्ट है तो मैं k का वैल्यू यहाँ पे 1 लूंगी. So that is x1. What is the value of x0? That is 6. K का value 1. What is the value of n? Value of n is 18. The value of d is 2. So the answer will be 15. Now, how can you be sure that your answer is correct? Whatever the solution you have find out, that is the value of 6 and the value of 15 is correct. So in order to do that, the common technique is just replace in your equation. What was your equation? Equation was 14x congruent 12 mod 18. ठीक है, यहाँ पे x का वैल्यू डाल डाल के आप जो है चेक कर लो. डेट इज x का वैल्यू अगर आप यहाँ पे 6 रखते हो and after performing the mod operation, the answer should be 12 because there is a congruence operator now. So the operation whatever is applied on the right hand side, it should be applied over the left hand side. ठीक, तो the answer यहाँ पे आना चाहिए. उसी की दूसरी इक्वेशन में आप देखो डाल के, that is 14 into 15 and after performing mod operation, the answer should be 12. You can check it. The exam you can your answers. Now the another question states 3x plus 4 congruence property mod 13. Now this equation is not in the form of this one. You have to make this equation in the form of this one because the plus 4 over there, so you have to add the additive inverse of 4 both of the sides. So what will be the additive inverse of 4 over there? So that is minus 4 over there and it will be 6 minus 4 and mod 13. Now the equation is 3x congruent to mod 13. Now this is the value of A, this is the value of B, and this is the value of N. Find out how many solutions are possible and what is the value of that solution. And tell me. Yes, one solution is possible. And what will be the value? Yes, the answer is correct. So GCD of A, comma N equal to 1. So the value of D is 1. So only one solution is possible. And what will be the value of that solution? So first you have to check out there is a deduction possible or not. So there is no need of deduction. Equation is already reduced. So go to the step 2. Step 2 says you have to multiply by the multiplicative inverse of A, both on the sides. Okay. What is this one? So 13 mod 13 into 2 mod 13 and mod 13. So ये कैसे करते हैं? You have to multiply by a value such a way that after performing the mod operation, the answer should be 1. So in that case, it will be 9. And 2 and mod 13, the answer will be 5. So this is all about the today's lecture. So in the next lecture, that is from tomorrow, we will jump towards the cipher algorithm. So first we have to learn about the symmetric cryptography. Then symmetric cryptography part is very, very large. And after finishing them, we have to jump towards the asymmetric cryptography, which is really tough as compared to the symmetric one. So symmetric cryptography is simple, but asymmetric is tough. So don't worry, I will be there for your help and to solve the queries. So if anyone has some doubts, you can mention in the chat, otherwise you can leave the meeting. Okay, no doubts. So thank you so much for joining the session.